Okay, good evening, ladies and gentlemen. Welcome back to another live office hour brought to you by Chegg. So today we're going to focus again on trig and precalc, and I have this question for you guys. Go ahead and figure out if you have sin x plus cosine x, this is equal to which of the following. So try this. In the meantime, we're just waiting for people to come in. And thank you so much for coming today. If this is the first time that you join our live stream, welcome. Thank you for coming. So go ahead and figure this out. And my name is blackpenredpen if you guys don't know it already. We will be back again next week. Same time, same day, Monday, 6:45 p.m. to 7:45 p.m. Today, we'll be doing trig and precalc, but if you need any other subjects, make sure you do check out the QR code from Chegg. They have other topics throughout the week for office hours, chemistry, computer science, calculus. Go check them out. I think there's also a link in the description. You guys can go click on it and then go check out the schedule. All right. So this is actually the question from last time. We just ran out of time, so I want to do this real quick. And later on, we'll be doing some rational functions because I figure we have been doing a lot of trig. And in precalc, there are two parts. Trig, right, the sine cosine business, and also the algebra, like more of the things that you have been doing. So today, after this question, I would like to go over some of the algebra questions with you guys. And in fact, those are the questions I am currently teaching in my class as well. So I think it will be beneficial to you guys. Okay, so let me just have a look. Welcome everybody, welcome everybody. Greetings. Okay, so sin x plus cosine x is equal to which of the following? I'll give you guys another 20 seconds. All right, hello everybody. You can also leave where you're from in the chat. What time is it? Right now it's 6:47 p.m. I'm located in SoCal. Oh, greetings from South Dakota. Wow, that's far. All right, this is a live stream. So if you put your comments in the chat right now, I can see, I can read it. All right. Let's go ahead and get right into the first one. Sin x plus cosine x is equal to which of the following? This is the question that we did last time, but well, somebody asked me, but I didn't have the time to go over. So today, we'll go over this. Anybody has the answer for it? I'm going to prove it to you guys. In the meantime, you guys can figure it out. How's that? I'm going to do a proof first. I think that'll be more interesting. Because the truth is, you can do this either way. You can expand this and see which one will give you this, or you can do the following. Have a look. This is a very, very useful formula. So here's the claim, right? The claim is if you have some number, right here, the number is just 1, some number a times sine x, plus some other number, let's say b, times cosine x. You can actually merge them together into some number right here. Usually people call this r. So this is also known as the r formula. And right here, you can either put sine or cosine. It's kind of like up to you. Right here, I'm going to choose sine. But here, the x stays. Inside, we have to have a shiftment, right? So plus another angle, let's say phi. This right here is possible. Now, the question is, we will need to know what's r and then what's phi. If we can figure it out, then that will be done. So how can we do this though? Well, start with this right here. R sine x plus phi. This right here is the same as r. The angle sum identity that we went over last time. Have a look. I'm going to just break it down as sine of the first plus, well, sine of the first times cosine of the second plus sine of the second times cosine of the first. And then distribute the r. Now, check this out. Right here, we have R. Okay. I know what you guys are thinking. I need a new marker, so give me 1 sec. Let me grab a marker right here. I hope it works. Okay. Here's R, much better, times cosine phi. This right here, we have to match it to, well, here was sine x, right? So we want it to match with A. And then let me just write that down. We must have A equal to R cosine phi. Okay? And then right here, if you do the same thing, here we have R sine phi, and that's pretty much the number that we need to make for capital B. So in the meantime, we also need B equal to R sine phi, like that. Okay, now check this out though. What I'm actually going to do is I'm going to divide, because remember the goal is to figure out R and phi. So what I'm going to do is I'm going to do this over that. So I'm going to do like this. B, which is equal to R sine phi, and then A is equal to R cosine phi. I'm going to divide this over that, this over that. Can we do it? Yes, because A is equal to R cosine phi. So I'm just dividing both sides by the same thing. Now, the beauty for this is that right here, R and R cancel, and then we can see that this gives us tangent phi, which is just equal to B over A. And that's our first condition. So condition number 1. So just write down condition 1. Okay. Now, what else can we get though? Have a look right here. I'm going to square both sides from here, here, and here. And I'm going to do it backwards. Like go this way. Have a look. On the left-hand side, we have a squared plus b squared. And on the right-hand side, we have r squared cosine squared phi. And then this right here is plus r squared sine squared phi. Now, we can factor out the r squared. And then we just get cosine squared phi plus sine squared phi. I'm sorry, right here, much better. Yes. And then, of course, this is the famous Pythagorean identity, which is just nicely equal to 1. And then right here, we can say that r squared is condition number 2. I'm just going to put on condition number 2 right here. Condition number 2. I'm going to write that down right here for you guys. I'm sorry. This is a squared plus b squared. I'm going to write it as r squared equals a squared plus b squared, like this. So that's condition number 2. All right, so take a look and let me know if everything's clear so far. And then in the meantime, I want to read you a chat. I want to read your comments. And I'm doing this for like the whole thing. And if you guys would like to use cosine, you can do the same as well. I'm just choosing to use sine. And then right here, I'm just using sine, the angle sine identity, to break it apart. And the idea is you mix match coefficients, right? R cosine phi, you have to match with capital A. R sine phi, you match with capital B. And then you go from there. And I want to read your comments. Okay, so far so good. And now I'm just going to erase all the complications. So this is achievable. All we have to do is the following. Remember condition number 1, condition number 2. As of condition 1, okay, for r, we have to make sure that r squared is equal to a squared plus b squared. And then remember for this, it was what? Tangent phi has to be b over a. So condition 1 and 2. All right, so you can see that we have 1 and 1. This is 1 and this is 1. So to get the coefficient right in front, it's just square root of 1 plus 1, which is that. But it's either A or C, right? It's either A or C, but I'm using sign, so of course you know the answer is going to be A. I will tell you the answer is indeed equal to A. Because the rest you can just plug into the formula. But I will show you guys this anyway though. Our equation right here is 1 and 1. So I'm just going to say we have r squared, which is equal to 1 squared plus 1 squared. And you can see that r is just equal to square root of 2. Now, b is 1 and a is 1, so tangent phi is equal to 1, and phi is equal to 45 degrees, which is pi over 4. And I'm not saying this is the only answer. In fact, this is just an answer. You pair up square root of 2 and pi over 4 for this, it will work. Because you can also think about another angle that makes this equal to 1. Yeah? And then you can also maybe use negative r. But you have to just be really careful. You have to make sure if you do use negative r, the angle has to be different. But I'm going to be leaving that to you guys. I'm not going to make it too confusing than it has to. So this is the way that you can do it. Right? So hopefully this right here is clear. And let me know if you guys have any questions. Make sure if you have questions that you have right now with your pre-calculus class, feel free to drop them into the chat. I will try my best to help you guys out. That's our goal. And if you guys need more help, we do have office hours throughout the week, right? Hosted by Chegg. So make sure you guys check out the QR code or maybe the link in the description. Follow Chegg on their YouTube channel, on their social media, so that you guys can get the information of the coming up office hours. So let me take a look at any questions, if you guys have any. So hopefully you guys all like that. And that's a really useful theorem though. Okay. All right, so somebody was just watching my integration by parts video. Thank you. All right, thank you guys so much for coming. Thank you guys for turning in. Okay, we are not doing calculus, unfortunately, but if you want to study calculus with Chegg, I believe the office hour for calculus is Thursday. But the best thing is for you guys to click on scan the QR code so you can get the most accurate information and subscribe to their YouTube channel. All right. Okay, I do want to do some algebra today, and this is about rational function. I think this is how I want to make this live stream to be, right? So pre-calculus, the algebra part. And here's a question for you guys, right? So I'm just going to consider, let's say we have this function, f of x, and let's say we have this equals x minus 1 over x squared minus 5x plus 4. And here are the things that you need to know for rational functions. First, actually, by the way, this is how picky I am. I use lowercase for part A, part B, part C. I use capital A, B, C for the answer choices. But anyways. All right, part A. How do we find the domain? How do we find the domain? So notice this is how the function is x minus 1 over x squared minus 5x plus 4. So just real quick, let me know what the domain is. And you have to be super, super careful. You have to go with how the function is written in the first place. You don't have to use interval notation in the chat. You can just tell me the bad numbers. Because I know in interval notations in the chat, it might be harder to type. So just tell me the bad numbers. Domain is not necessarily equal to the vertical asymptote. They are related, but you have to be careful. Because the numbers that you get from the domain does not necessarily give you the vertical asymptote. All right, time traveler, thank you. Thank you for coming back again, and thank you for your answer. Yes, the domain is you just look at the denominator, which is x squared minus 5x plus 4. You make it not equal to 0. I know. Okay, I have plenty of markers. All right, we make it not equal to 0. And then we can just factor it. So x minus 1, x minus 4, not equal to 0. From here, you can see that x is not equal to 1. From here, you can see that x is not equal to 4. So that's pretty much it for the domain. And now, it depends on how your instructor wants you to write down the answer. The domain is a set of all possible x values that you can use for the function. Right here, we are saying x cannot be 1, x cannot be 4. So the first way is you can use the set builder notation, which is like this. All real number x such that x cannot be 1, x cannot be 4. So this is one way to write down the domain. Another way is if you use like certain textbooks, they will like you to use the interval notation. In that case, you will write from negative infinity up to 1, parentheses because you are not including the 1, union, not including the 1, and up to 4, again, not including the 4 either, union 4 to infinity. And you never include infinities. So it's like this, all parentheses, right? But the key is right here, and that's the domain. That's it, done deal. Done deal. You can also write r minus 1 and 4. That's fine too. It really depends on how your instructor or how your textbook wants you to write down the answer. Now, usually we talk about domain and range, but not yet, not the range yet, not the range yet, because it's harder. Because for the range, you need to come with a graph. It's better. Sometimes you even have to do calculus for the range, but not yet. Now, part B, we are going to classify which number gives you what. Part B, let's talk about where is the vertical asymptote, VA, vertical asymptote. now what though? Where is the vertical asymptote? Perhaps I'll spell it out. Part B, and I'm going to leave a space. You guys will see why. Vertical. ASY and PTT, something like this. Usually I just put down VA. So, what do you think what the answer is? What's the vertical asymptote? So time traveler, you got it right, and mount to 2, 3, 4, 6 to find the vertical asymptote is to see what value makes the denominator 0. Well, we did that, and we got two numbers that make the bottom equal to 0. But now we have to be careful because not both of them will give you VA, vertical asymptote. Right? Now let's go back to here because I know many of you guys noticed. Right here, we could have factored out the denominator right here, x minus 1, x minus 4. Better yet, x minus 1 cancel out with x minus 1. I don't know what happened with my markers today. Plenty. I'm just grabbing the old ones. Let me see. Much better. So we end up with 1 over x minus 4, right? So now if you look at the graph of this, I'll just put it down right here real quick. We have 1 over x, which looks like this, right? It's like this and like that. But you have to move the graph to the right 4 times. So 1, 2, 3, 4. And here is going to be the vertical asymptote. Because we still have the x minus 4 on the bottom, and the graph of it, it's going to look like this. Like this. And like that. All right, so this is the graph of it. Okay, but now be really, really careful. We move the graph 4 times to the right. So the vertical asymptote is at x equals 4. And this is how you answer it. At x equals. right? Exactly equal because we're talking about this vertical line. So this right here would be the answer. But now here's the problem though. Where's the 1? Right? Because didn't we say that x cannot be equal to 1 either? So here is the deal. If you look at the graph, this will give you this. Right? This graph is 1 over x minus 4. But the issue is, when we cancel this and that, we have to make sure to say x cannot be equal to 1. So on the graph, this is how you have to indicate that. This is 1, 2, 3, 4. But x cannot be equal to 1 because that's our domain. So you have to come here, the 1, and then you go down, erase the graph a little bit, just like take it away. And then to emphasize that, you have to put down a little open circle. Like this on the graph. Right? So this is really the graph of that. Okay? And when I first learned this, like many years ago when I was a student, yeah, it was confusing. But hopefully this right here, I can make it clear for you guys. It did take me a while to really grasp all this information. This right here is just a hole on the graph, especially a pre-calc. Most of the books that I use, they just call it a hole. So right here, we're going to say at x is equal to 1. So have a look though. Domain x cannot be 1, cannot be 4 because you make the denominator equal to 0. But at 4, you still have the vertical asymptote because that didn't get cancelled, right? That didn't get reduced. But the whole, which is the one that got cancelled, like this. Now, here's a question though, because what if we want to find the coordinate? Coordinate of the whole. Well, if you look at this right here, right? When x is equal to 1, we will need to know the y value. And to do so, in fact, we can just plug in 1 in here. Have a look. We can just go ahead and do 1 over, put a 1 in here, and then minus this 4, which will get negative 1/3. And this will really give you the y value right here. Do not plug in 1 into the original, because otherwise you get 0 over 0. If you put a 1 into here and here, you get 0 over 0. So a good indicator is you get 0 over 0 from the original. For the vertical asymptote, you see if you plug in 1, so if you plug in 4 in here, you get 1 over 0. Vertical asymptote is when you have a non-zero over 0. Of course, there are some trickier cases than this, but I'm not going to get into that. This is meant to be for pre-calc, so usually this right here will be enough for you to solve most of the questions in pre-calc. You wouldn't see like super tricky questions. But as I mentioned it, this is the y value of the open circle, so the coordinate of the whole is at the point 1 for the x, and then y is negative 1 over 3. So this is the x, this is the y, this is not the interval notation. Right, so let me pause for a little bit. Let me know if you guys are okay so far. If you have any questions on this, let me know. If you're also doing this in your pre-calculus last class, let me know that too. Can you have both VA and the whole not at the same x value? Not possible. It's like once you have a vertical asymptote, there's no way for you to put the whole at there, right? And once you have the whole, there's no way for the graph to go straight up or straight down. No. All right. Lastly, remember earlier I told you guys when we were doing these questions, you have to know the domain and also the range, right? So part D is the range. And for the range, you really should look at the graph. You really should look at the graph. Otherwise, I wouldn't know how to do it either. That's why I went through this right here, especially for the whole. This is like the point that people missed. Seriously, this is like the point that you guys will miss on the test as well. Be careful with it. Now, you can see that y goes all the way down, so you can go from negative infinity but you are not going to get -1/3. So for the range, we go from -infinity up to -1/3, not including, not including. And then from -1/3 to 0, we are not including 0 either. So the range is the y values cannot be -1/3 and also cannot be 0. So let me just put down the inequality like this to make it clear. Any other y value will work. So you go from -infinity to -1/3 and then union, and you picked up from -1/3 to 0 and then union, and then you go from 0 to infinity. Like that. So this right here, it's in pre-calc, and I know some of you guys noticed this right here is also like it feels some calculus behind it, right? All right. Okay, so for the people just coming, thank you guys so much for joining us for the live office hour today, brought to you by Chegg. Make sure you guys scan the QR code so you guys can get more information. And we do have office hours throughout the week. And I will be back next week for you guys, Mondays, right? We'll be back here on Mondays from 6:45 p.m. to 7:45 p.m. Pacific time. Pretty much during this time for an hour. All right, so take a look. Let me know if you guys have any questions. Okay. So let me erase this real quick. And then if you have any questions that you're doing in your pre-calculus class or your trig class, feel free to let me know too. Okay, let's see. I'm looking for the questions in the chat. And thank you guys so much for leaving messages. Thank you. Thank you. And then, oh, somebody is doing calculus too. Infinite series. I think it's on Thursdays. Check out the QR code though. I think it's on Thursdays. Tyler Wallace will be back holding office hour for you. So yeah, Wallace stamp. So yeah, he's great. He's great. So make sure you check out the schedules. How about good question. What about slant asymptote? Before we do that, can we do like a normal asymptote first? Yeah. Oh, I forgot to mention about the horizontal asymptote earlier, but horizontal asymptote was 0. But let's do a vertical and horizontal asymptote first. Yeah. So let me make sure I'm not covering the QR code. So this time, let's consider, let's say we have a function. F of x is equal to, let's do this, 3x minus 4 over x minus 2, something like this. And perhaps let's figure out the graph for it, because the moment that you know the graph, you pretty much can answer everything. So how can we graph this? Help me out. Let me know. Don't say use a calculator. How can we graph this? What's the first step that you do so that you can get a better idea of like, what's going on with this? You can find the 0 for this right here, but that will give you the x-intercept to get a better idea of what's going on right here. Yes, you can also find the vertical asymptote, in the meantime horizontal asymptote. Here, let me show you guys how we can do it. And some of you guys might know the shortcut for this, right? The shortcut is, let's do this real quick, right? The vertical asymptote It's really hot today, by the way, so maybe that's why my markers are drying out. Anyways, vertical asymptote is the denominator equal to 0, right? So it's just at x equal to 2. And we have to make sure when you put 2 in here, 2 times 3 minus 4 over 2 minus 2. This right here gives you 2 on the top over 0. So it's a non-zero over 0 case. So vertical asymptote at 2, that is okay. Right? Now, for the horizontal asymptote, this right here will be at y equals. In fact, you can just look at this number over that. Divide out the x, you just get 3. So that's the quick way. It's the 2 and then 3. And you can do this when you have a linear over linear. Ax plus b over cx plus d. So assuming they're all different, of course, or they don't cancel out immediately. Otherwise, it's kind of not a rational function anymore. So whenever you have this expression to find the phi a, you just make it not equal to 0. Well, I'll just say like this. Phi a is you set cx plus d equal to 0. And then for horizontal asymptote, it's just going to be y equals a over c. Well, that's the quick way to do it. But why is that though? I'm going to show you. So now let's practice, let's review either polynomial long division or the synthetic division. Let's do the polynomial long division first. So right here, I'm going to put the top inside 3x minus 4 and then the x minus 2 on the outside. 3x and x, we need 3, right? So put the 3 here. 3 times x is 3x. 3 times -2 is -6. Subtract. -4 minus minus becomes plus. -4 plus 6 is positive 2. This minus that is, of course, 0. So either you do it like this, or you can also run through the synthetic division real quick. If you do the synthetic division, you put down the coefficient here, which is just a 3 and -4. Now, on the bottom, it's x minus 2. So you put positive 2 on the outside. And then you bring down this 3, which is right here. And you do 2 times 3, which is 6. You put it here. And you add them up when you do synthetic division. This right here is 2. This is the remainder, just like how we got here. This is 3, just like how we got it right there. So either way, though, here we can see that f of x is equal to 3x minus 4 over x minus 2 becomes the 3 is by itself, but the 2 is over the original denominator, like this. All right? So once you see this, you can see that, okay, 2 over x minus 2, when x is equal to 2, you get the vertical asymptote, and this right here, just bring the graph up 3 times. So just real quick, here is how you're going to do it. I'm going to do it one step at a time. This is 1 over x. And this is y is equal to 1 over x. Next, if you just talk about the shape, when you have y is equal to 2 over x, it's just pretty much the same shape when you multiply by a positive number, okay? Now, transformation. If you have y is equal to 2 over x minus 2, then the minus 2 tells you to bring the graph twice to the right. So here we have 1, 2. So I'm going to have the graph right here. It's like this and like that. Okay? And then lastly, if you want, let me actually erase this right here. This is y equals 2 over x minus 2. And then lastly, if you want y is equal to, here we have the positive 3 plus 2 over x minus 2. You just have to bring this graph up 3 times. So here, this is 1, 2, 1, 2, 3. So you have the horizontal asymptote here, and the vertical asymptote over here, and then the graph looks like this, and this is the final graph, so I'll put this down in red, like that. Okay, so it's just like this. So horizontal asymptote at y is equal to 3, vertical asymptote at x equal to 2. Okay, any questions on that? Graphing is not required, but I think it's just really good that if you can graph this. Because I showed you guys how to get the answer without doing graph, right? I showed you guys a shortcut. And this is the reason why the shortcut works, right? Now, let's do one with slanted asymptote. Again, the key is actually to do long division. So to answer your question, let's take a look at the following. And do you have a nice one though? You can maybe leave in the chat and let me know. If you have a specific question, you can let me know. If not, I'm going to come up with one real quick. I'm going to just cover it and then let's see how it is. All right, let's try this one. Consider f of x equals x squared plus x minus 3 over x minus 2. Okay, this is not factorable, right? This is not factorable. The numerator is not factorable. By the way, you should be able to tell the vertical asymptote right away, right? It's just at x equals to 2. And if you plug the 2 into the numerator, 2 squared is 4 plus 2 is 6. 6 minus 3 is 3. So it's not 0. We don't get a 0 over 0 case. So vertical asymptote at x equals 2. But how about, okay, here's the deal. If the degree on the top, let me do it like this. Notice right here, this is x squared. On the bottom is x to the first power. If the degree on the top is bigger than the degree on the bottom, then no horizontal asymptote, because the graph will go to infinity or negative infinity. But there will be what we call the slant asymptote. So right, we will have the slanted asymptote, and the goal is to see how we are going to find it. By the way, can you guys see the red? Okay, let me know real quick. How's the red? Okay, let's change it regardless. So, but we have the slanted ASY, right? Slanted asymptote. So how do we do it? The key is just all about division. Polynomial long division or synthetic division, up to you. Let's have a look. I'm just going to put down the top on the inside, so x squared plus x minus 3, and then the bottom on the outside, so this is x minus 2. Now, compare the first thing inside and then the first thing on the outside. We need x, because x times x give us x squared. Next, x times -2, which is -2x. And then after that, we are going to subtract, like that. X squared minus x squared is 0. X minus -2, that's what? X plus 2, which is 3x. And then continue by bringing down the minus 3. 3x and x, we need plus 3. Plus 3 times that is 3x. 3 times that is -6. And if you subtract, this is -3 minus minus becomes -3 plus 6. So at the end, it's positive 3. Of course, you don't need to write down the plus. I just wanted to emphasize that. And in fact, you know the slanted asymptote already. This right here. This is the line. So that's why it's a slanted asymptote. The slanted asymptote is y equals x plus 3. So vertical asymptote at x equals 2. This is a vertical line. And the slanted asymptote, it's a line with a slope, so it should be like this. And just to review the sensitivity division, right here, draw a box, well, half of the box. Write down the coefficients. We have 1, 1, minus 3. 1, 1, minus 3. This is x minus 2. So you put down capital 2, no. You put down positive 2 right here. And then you bring down the 1. Okay, continue. 2 times 1 is 2. Put it here. We add them up. Sensitivity division, we add them up. 1 plus 2 is 3. And then continue. 2 times 3 is 6. Put it here. Negative 3 plus 6 is positive 3. This is the remainder, though, which is the same as that. Now, either way that you do, you should be able to write this function as the first part, which is x plus 3. And if you look at this right here, this is 1 times x, because originally we have x squared, but we divided by x to the first power. So the power goes down by 1. And this is just a constant term, so it's just plus 3. And the remainder, you just put plus 3 over the denominator. And the idea of this right here being the slanted asymptote, let me just write this down, slanted asymptote. It's because when x gets really, really big, let's say 10,000, 3 over 10,000 minus 2, it's a very small number. This is almost 0. So when x gets really, really big, positive infinity or negative infinity, this part doesn't matter. This part will be dominating, which is just a line. That's why we call it a slanted asymptote. So the graph will be like this. When x is equal to 2, here we have vertical asymptote. So I'm just going to put it like this. And then when we have a slanted asymptote, okay, y is equal to x plus 3, right? So this is 1, 2, 3. Starting at the y-intercept, 3, and then the slope is 1 and 1. 1 over 1. So you have this point and then that point. And then, okay, I know I don't have enough space. I'm just going to do it again. Here, let's try it. Here is 1, 2. Here is our vertical asymptote. And then let's say this is 1, 2, 3. Okay, starting at 3. Slope is 1. So you go up 1, and then go to the right by 1, like this. And then you're going to put down the slanted asymptote. So that's the red one. That's the slanted asymptote. Now, which one though are we going to get though? Okay, this is how you can do it. You can plug a point that says when x is equal to 1. If x is equal to 1, then you can see that, okay, if x is equal to 1, plug in here, then f of 1 is 1 plus 3 plus 3 over 1 minus 2. That's 4 minus 3. So it's equal to 1. So 1 is 1 right here, right? So you know that the graph will look right here, will be somewhere right here. And when x is equal to 0, we get positive 3 over 2. So I'm going to just go ahead and do something like this. So this part of the graph will be right here in this little triangular area. And then the other part will go like this. And remember, we have the vertical asymptote that you cannot touch. So it's like this and then like that. And of course, the graph is not, my graph is not perfect. If you use a computer, you can see the shape of the graph should be like this. Okay, that was fun. Okay, let me know if you guys have any other questions. Can you graph the slanted asymptote? Yes, I just did that right here. You graph the line. And in fact, if this term turns out to be a quadratic, then you have a parabolic asymptote. Just a parabolic. Well, that's like, at the end, slanted asymptote means that you can see that the curve becomes just like the line. If you have a quadratic here, you can see that the graph eventually will look like a parabolic. Okay, so that should be enough. And now let me erase this. If you have any questions in Trig or Precalculus, feel free to drop them in the chat. Today, we have been going over like rational functions, asymptotes, and things like that, which they are really confusing topics. And in fact, I'm also teaching this with my students right now as well. And we also did a R formula in the beginning of the stream, so that was fun. Okay, where's my marker? Okay, cool. Now, let me just take a look. Can we do logarithm? Sure. If you have a specific question, then we can take a look. Oh, how about this? Because you ask, I think this is the formula that people should really know, how to evaluate logarithms without using a calculator. So for example, like this right here might be scary looking, right? Let's say log base 8 of, let's say, 16. What's the answer for this? What's the answer for this? Well, just precalculus is not covered in lambda W function is not covered in precalculus, so we are not going to be able to do that. But for log, yes. What's the answer for this, though, real quick? Without a calculator, log base 8 of 16. You should be able to get a fraction for it. Can you improve the video quality? I think the video quality is okay, right? You guys can let me know. I think it's pretty good. I might try to improve my lighting. I think that might help. But for now, let me know if you guys can see well. Okay, I see a lot of you guys get a correct answer. This right here is not equal to 2 though. Yeah, because it looks like 16 and 8, right? This right here is not equal to 16 over 8. It's 4 over 3. But here's a fast way to do it. I love this way the most. Whenever you have log of a base and then 16, yeah, make sure to make them the same base. If the question is asking you to do this without calculator, then you can almost always make them into the same base. Sometimes it's tricky, I don't even know, but most of the time. That's why I say almost always. Anyways, here's log. 8 is 2 times 2 times 2, which is 2 to the third power. 16 is the same as 2 times 2 times 2 times 2, 4 of them. So it's 2 to the fourth power. Earlier, as I mentioned, that this is not equal to 16 over 8, right? It's not equal to 2, so not this. But if you look at it like this is equal to 4 over 3. That's the answer. Yeah, that's the way to do it. I love this so much. And I think like more students need to know this because logarithm is not so bad if you know this. You just have to make sure they have the same base, and then you can just do this power over that power. Now, why is this true? I'm going to show it to you guys. So here's the change of base formula. Log base 8 of 16. You can first write this as log of 16 over log of 8. Now, this is okay, not this. And of course, right here, we cannot cancel the log. No, that's not it either. Okay, next. Again, we are still going to consider 16 as 2 to the fourth power. So this is log 2 to the fourth power. And on the bottom, this is log 2 to the third power. Bring the powers to the front because of the log property. And then you can see that we have 4 log 2 over 3 log 2. Now, log of 2, they are just numbers. Now we can cancel them out because they're the same number. So finally, you can see that the answer is just 4 over 3. Done. Oh, thank you. I just got my hair cut today. Thank you so much. Okay, let me see if you guys have any other questions. Oh, since we are on the vertical asymptote and all that stuff, here is the log graph that you should know. If you have y is equal to any log, but most of the time, especially once you're in pre-calc and calculus, we talk about natural log the most. The graph looks like this. So the x-intercept is when x is equal to 1. So I want to mention that we do have vertical asymptote. This is another case that you are going to get vertical asymptote is with log functions. Vertical asymptote at x equal to 0, and then no horizontal asymptote. Because this right here, if you just look at like a separate part of the graph, it might look like it's going to be flat. But no, you have to know that the bigger the x value gets, the bigger the y value also gets without boundary. So that's why there is no horizontal asymptote for logarithm. But for the vertical asymptote, this is the case that you pay attention to log of 0 inside. So that's another case for the vertical asymptote. How do you find the range of this function? The range for any function is best when you have a graph. So if you look at this right here, the range, because the graph goes all the way down, and then as I mentioned earlier, this right here will keep increasing without any boundary, without any limit, without any horizontal asymptote. So the range is just going to go from negative infinity to positive infinity. But the domain for this, we cannot have 0. So not including 0, but you can have whatever x value that you want as long as it's positive. So the domain is from 0 to infinity. The range is negative infinity to infinity. Can you explain the dot product and factors? Do you have a specific question though? Because if you want me to do like a lesson on that, we have only 7-8 minutes left. I don't think we have enough time for the whole thing. My arm gets tired. That's why I do this once in a while. All right, for the people who are here, thank you guys so much for coming though. I really do appreciate you guys joining us today. And we will be back next week, same time, right? Monday from 6:45 p.m. to 7:45 p.m. And this live stream, all these live streams are brought to you by Chegg. Make sure you do scan the QR code, especially if you also want to join other live streams from other instructors. Go ahead and check them out. Make sure you follow their YouTube channel, their social media, Instagram, all that stuff, so you can get the most updated information. Did we do the inscribed rectangle problem from last time? We didn't do it yet. Maybe we can do it next time. That's a really good question. So the question is, can we show the general formula for the inverse of the function ax plus b over cx plus d? I think we should be able to do that. And that is exactly what we're talking about today, about rational functions. So totally. Rational functions are one of the hardest things for in pre-calculus. So yeah, anyways, I'm just going to say that f of x equals ax plus b over cx plus d. And then we are going to find the inverse. Now, let's just do the math. We have 6 minutes. So, step 1, I'm going to write this as y. Y equals ax plus b over cx plus d. Step 2, the key for inverses is you switch x and y. You swap them, you interchange them. So, instead of y, you have x. Instead of x, you will have y. And then the rest, they are just numbers. They're just constants they maintain. Now, all we have to do is to isolate this y. Let's multiply this to both sides. So we have x times cy plus d. It's equal to ay plus b distribute. So, let's see, cxy plus xd, don't write dx, so xd. Anyways. And then this is ay plus b. Now, I'm going to subtract ay to both sides because we have to put all the y's together. And then I'm going to subtract xd to both sides. So this and that to the other side, this will go here. And here we will get cxy minus ay equals b minus xd. Yeah. Now, we have the y here and here, so we can factor it out. Here we have the y, and then cx minus a equals b minus xd. Now, divide this to both sides, so we get y equals b minus xd. I really want to, I don't know if I should put dx or not. Okay, let me just finish this, cx minus a. So that's pretty much our inverse. Right, that's pretty much our inverse if you don't really care about the form of it. But if you do, usually we may want to write down the x term first, right? So perhaps let's put this down right here first. So I will just write it down like this. This down right here first. And that's really kind of abuse the notation. I'm going to write down dx. And then this is positive b over this right here, cx minus a. Just like that. So this right here will be the inverse function. Let me see, b minus xd over cx minus a. Yes, time traveler, I have the same answer as you. Cool. You have the same issue as me? Then what do you mean same issue? You mean the dx xd thing? All right, so let me know if you guys have any questions right here. And again, thank you guys so much for coming here today, though. We are about to run out of time. We have about 3 minutes left. So I'm really grateful that I can join Chegg and then brought you guys the live stream like in this on Mondays. We'll be continue doing this until May. So you can expect to see me again next week, Monday from 6:45 to 7:45 p.m. Pacific time, pretty much during this time period. But I know right here we're just doing trig and pre-calc. If you need help with any other subjects such as chemistry, physics, computer science, calculus, make sure you scan their QR code to check out their schedules. We have other instructors that will help you with your topics, right? So make sure you do that, and I really appreciate you guys as well. Oh, your birthday is tomorrow. Happy birthday. Happy early birthday. Yeah, the dx looks like a differential, totally. Oh, I'm happy to hear that you like the slanted asymptote. Just solve the Riemann sum. That's calculus. What do you call it? Okay, let me see. Well, if you guys have any like particular question, if you're taking trig or pre-calc, if there's any questions that you guys would like me to answer, you guys know my channel. You guys can just like leave a comment. Maybe in this live stream because there's playback, right? So if you just joined it right now, if you missed the first hour, if you missed what happened earlier, you can come back to this and then watch it, and then you can just leave a comment in the comment section. Especially if you have questions on this, or maybe you have the question for the next live stream, leave a comment. I'll be happy to see what I can do for you. All right? Okay, again, thank you guys so much for coming. Thank you. And I will see you guys next week.